I know. Can't get over it. Oh well. I want to go through the notes quickly so you have time to get your homework done. There's not that much. Second period is normally on it anyway. Last week I missed a lot of days, and for that I am sorry, but second did a great job of, well, most people did a great job of turning stuff in. If you're not one of those people. Well, I know I've already checked the study guide situation. Did you turn in your blue review sheet from last Wednesday? And then, of course, there's still those who miss turning in, like, the special right triangle coloring page or the special right triangle worksheet. So I would make sure I had all my stuff there. At the moment, most people in the room are doing great for this semester, or at least for this 9 weeks, and those who aren't doing great for this 9 weeks still have a very good fighting chance in the semester, as long as we keep it together to the end of the 9. There are still a couple who haven't turned in their projects, their Pythagorean theorem projects. As of today, the highest you get is a 30 out of 60, but that's still better than a 0, and maybe I would feel sorry for you if you had done a stinking awesome job and give you higher. I am kind of a sucker. So, hopefully you've done something about that. We spent forever, like we spent all 2 weeks ago on 45, 45, 90s. All last week on 30, 60, 90s. So, I was not very forgiving, especially with you on the tests. But still, it was one of your highest averages. So, I'm very pleased with that. I want to go over the notes quickly. I already said those words. There were other words I was going to use. Oh, yes. Today is the important day. Today we start the trig part of geometry. If you're going to, after me, take Algebra 2 with trig, pre-cal or cal, pretty much any math after me, you're going to need what we talk about today. We're going to do something called right triangle trig. Now, all the little shortcuts we learned about special rights is still going to work. There was no one in this classroom who made this mistake, but I do want to point this out while it's on my brain. There were some who on the first, I know at least one person in 8th period, on the first page of the test, they didn't use Pythagorean theorem. If you're given 2 sides of a right triangle and you're asked to solve for the third side, it's Pythagorean theorem every single time. There were some who tried to turn it into a 30, 60, 90 issue or a 45, 45, 90 issue. How would you know you were supposed to be using special rights? How are we going to know on a standardized test when to use the Pythagorean theorem and when to use our special right triangle tricks? Are the angles labeled? Did they label the angles the way they did in this problem? They have a 60. Danny's right. How else would I know that this one is a special right? The radical definitely gives it away. That's true. And then there's one more obvious reason why this is a special right issue, not a Pythagorean theorem issue. The x and the y. If it's a Pythagorean theorem, we're only missing one side. The fact that we're missing 2 sides means it's a special right issue. Okay, I just wanted to throw that out there, so if you see this on a standardized test, you don't suddenly blow it. What's the hypotenuse? Okay, and then what is the long leg? I don't need the number, I just need the labels first. Okay, this is the long leg, and then what's this one called? Okay, how do we go from the long leg to the short leg? Okay, I had some people on the test who just divided by 3, not square roots of 3. So they would have gotten this wrong. They would have had 2 square roots of 3 when the answer is 6. How do you go from the short leg to the hypotenuse? So 6 times 2, which is 12. The hypotenuse is 12. Okay, but the good news is I stole this from a standardized test question, and I deleted the answer choices. So you were able to solve that quickly and easily without the A, B, C, D options. So that's terrific. That's terrific. I still have one person who's not labeling their triangle correctly. I can forgive you for short leg and long leg, but you've got to stop messing up the hypotenuse. If you mess up the hypotenuse today, it's like a house of cards that's going to fall straight down. Okay, on our second bell ringer today, what am I supposed to do first? Am I supposed to deal with that radical first? What if I tell you the answer to that is no? What am I supposed to do first? I would add 6 to both sides, thank you. So I would have square root of 5 minus 4x equal to 13. How are you wanting to deal with the radical, David? How do we get rid of it? That is a good question. How do you get rid of the radical? You square it. Okay, so the house goes away, and I have 5 minus 4x equals 13 squared. What is 13 squared? Okay, so 5 minus 4x equals 169. I subtract 5 from both sides. I get negative 4x equals 164. So x equals, it's negative something. 40 what? Yeah, it's negative 41, which is g. Okay, so the moral of that story, what I thought of while I was doing that, is there was one person in the room, had the Pythagorean theorem down, has it down pat, gets to the last step, and they had like c squared equals 25, and instead of taking the square root and getting c equals 5, they left it here, and they just said c equals 25, and they circled that, and they missed off 2 points on at least 5 questions. 5 questions they missed 2 points. All because they didn't do the last step. So if that's you, and you're going to know it's you when I hand you your test, then please don't make that mistake anymore, because if you think a standardized test person isn't going to put 25 and 5 as options, they are. They know where you make mistakes. They're not dumb. Okay. Moving on. Today we're going to talk about trig, which involves 3 new vocab words. If you say these words wrong, I will correct you. I cannot. I just cannot. I know the first vocab word looks like the word sin, like in the Bible, sin. I get it. It's not sin. We call it sign. Sign. No, different kind of sign. S-I-G-N, not like a stop sign. This is a different kind of sign. Different kind of sign. You know. So, they abbreviate it, and when they abbreviate it, they drop the E, and then it looks like sin. But if you say sin, I'm going to be mad. It's sign. Sign, sign, sign. And then the C-O-S, I know, Lord help us. They're going to think when you get to the next class that your math teacher did not teach you any math. If you call it sin, you've got to say sign. They at least need to know I taught you the right vocab term. Okay, the C-O-S is cosine. And then the T-A-N is tangent. So we are learning 3 new vocab terms today. One is sine, one is cosine, one is tangent. Eventually, later on in a future math class, those who love math, those 3 words will be fundamentally important to you. They're going to make some really cool things happen. Sound waves, everything else really cool in life probably has something to do with sine, cosine, and tangent. But for us, in geometry, where we live in this triangle world all the stinking time, all it's going to tell us is what sides we want from the triangle. Those words tell us which sides we want from the triangle. What we're going to do today is called right triangle trig. Clearly, since I said that, you can only use right triangles. Right triangle trig, you have to have a 90-degree angle. Does anyone know the acronym that we use when we deal with sine, cosine, and tangent? Does anyone know like an acronym we use in math class? PEMDAS. Please excuse my dear Aunt Sally. That's an acronym. What's another acronym we use in math class? Yes, ma'am. It is. I say SOHCAHTOA. Some people say SOHCAHTOA. I'm not really sure which one's right on that one. I say SOHCAHTOA, but some people say SOHCAHTOA. I need to throw this one away. Okay, so it's SOHCAHTOA. SOHCAHTOA. That acronym is like PEMDAS, meaning PEMDAS was please excuse my dear Aunt Sally, and it told you I do my parentheses first, then my exponents, then multiplication and division, etc. In the same way, SOHCAHTOA tells us what to do in the problem. If you have trouble remembering things like SOHCAHTOA, I'm going to post a cute little YouTube video to try to help you out. But also, there's a cute little acronym that I've learned, and I'm going to change one of the words because I'm not trying to get in trouble in math class today. If you're trying to remember this, one way to do it involves hippies. So you could say, some old hippie caught another hippie tripping on, I'm going to say apples? But yeah, it's supposed to be yes. Oh, yeah. Some old hippie caught another hippie tripping on acid, as Grant already knows. Thank you, Grant. I'm trying not to say Grant acid on my YouTube video, and Grant's blurted it out. Okay, so you're saying this comment. I don't know what that means, and I don't know what this has to do with anything we've been doing lately. Like drug use. Yes. Yes, that's why I didn't want to say it in that loud. Okay, so big picture. I don't even care. I don't even think about that. I just do SOHCAHTOA because I just know that acronym. It's easier. Okay, let's focus again. We can get it together. The part of the triangle you're never going to mess up is called the what? This is always the hypotenuse. That's the H. Every single time. So obviously we need the hypotenuse with side, and we also need the hypotenuse with cosine, because it's the S is for sine, the C is for cosine, and then the T is for tangent. And this little acronym helps me figure out what fraction goes with who. So obviously, let me zoom in on that. Obviously, we're going to need the hypotenuse for sine and for cosine, but tangent doesn't have an H, so we don't need the hypotenuse for tangent. And everyone knows where the hypotenuse is in the triangle. You're not going to mess it up. You cannot mess it up. Okay, last week with 45, 45, 90s, we would call the other sides of the triangle, we called them legs. And then when we did 30, 60, 90s, we had long leg and short leg. Today, we're not even going to call them legs. We're going to have opposite and adjacent. So the O is for opposite. The A is for adjacent. You can label it out all if you want to. I'm even going to write it again over here. So sine, we're wanting opposite over hypotenuse. S-O-H. Sine is opposite over hypotenuse. Cosine is C-A-H, so we want adjacent over hypotenuse. Stop, please. And then tangent, that's T-O-A, so we want opposite over adjacent. Now for today, I'm going to write out that every single time. So for instance, on this one, I want opposite over hypotenuse. Do I actually do that from here on out in math class? No. Hopefully you can figure it out pretty quickly on your own. If Trey's are trying to make sure he gets 100 on the test, it's always a good idea though. Okay, so the next question would be, Ms. Compton, how do we decide who is the opposite and who is the adjacent? And honestly, it depends. It depends on what I'm going to call our reference angle. What is our reference angle on number 1?
L.
L. It says sine of L. So we're going to be looking from L. So if we're at L, we're at angle L. What side is opposite of angle L? The 12, the 35, or the 37? The 12. So this would be the opposite. And we already know this one's the hypotenuse. That makes the 35 the adjacent. Okay, and because my second period is so smart, I'm going to go ahead and do 1, 2, and 3. So number 1 is opposite over hypotenuse. We're saying opposite is 12, so 12 over 37. Cosine is adjacent over hypotenuse. Adjacent is 35, so 35 over 37. And then tangent is opposite over adjacent. Opposite is 12, adjacent is 35, so 12 over 35. I'm not technically done today. No one in second period did this, but I did have someone in 8th period who on their test for the first couple, they wrote yes or no instead of acute, obtuse, right. That means they didn't follow directions. Have I followed directions today on these problems? No, why not? Decimal to the nearest. So how many places? So we need 2 places, 2 decimal places. So I need you to type 12 over 37 in your calculator. What did you get? 12.32. 0.32. Okay, and again, you know how to round. If it was 0.35, we would have rounded up to 0.33. Okay, and then 35 divided by 37. I typed that in. What should I put on my paper? Yes, and the reason we're doing 9.5 instead of 9.4 is because we have on the calculator screen 9.45. That 5 is going to round up that 4 to a 5. You know how to round. You're going to have to do that today. Okay, and then 12 divided by 35.
34.
Okay, perfect. Are there any questions about how we got these first three answers? Okay, well then our whole life is going to change on 4, 5, and 6. We're still going to do opposite over hypotenuse for sine. The acronym's not going to change, but the numbers are, because something has changed. What's changed on number 4? Yeah, we're the angle. We're going to ask from n. So if n is where we're standing at, what side is opposite of angle n? So that would make this the opposite. The hypotenuse, it doesn't change. But the 12 would then be the adjacent. So it depends on which angle they're asking us from. That's the big thing today. Which angle are they asking you from? So the opposite over the hypotenuse would be 35 over 37. But the good news is Alex doesn't have to type that into his calculator because he's already done it before. He knows it's 0.95. Why does it match? That's a good question. Wait till we get even further. Okay, a cosine is what? What's my fraction? Adjacent over hypotenuse, and then you told me it was 12 over 37. I already know what the answer is then. It's 0.32. Notice these two matched and these two matched. Yes, they were supposed to. So then you're thinking, oh my, does that mean the tangents match? No, they do not. Okay, tangent is opposite over adjacent. Well, the opposite is 35. The adjacent is 12. So actually, we got a different fraction. We flipped it. I'm going to have to type that into my calculator and see what it is. It is. It was 2.916, and that 6 is going to round up that 2, so 2.92. Okay, and then David noticed that these were matching. Why is everybody matching? That's kind of weird, and it's because the opposite of this angle is the adjacent for this angle. So we keep using the same triangle. They keep having the same hypotenuse. No wonder a bunch of their answers are going to match. If your tangents match, you've done something way wrong. Because one's from L and one's from N. Okay, so we're going to do the next couple together. The next 6 we're going to do together again. Are there any questions about those top 6? Okay, so what I want to say is that if you had your triples down, the next one is technically a 3, 4, 5. So instead of doing 16 over 12, I could do 4 over 3. I could reduce my fractions. Do you have to do that? No. Again, if you've read, it says express each as a fraction and as a decimal to the nearest hundredth. So am I going to count off if you don't reduce your fraction? Probably not. But it sure would make your life easier if you recalled those triples. Okay, so let's do the sine, cosine, and tangent of A. What is the sine of A? It is opposite over hypotenuse, but what is the opposite? What is the opposite of angle A? What number? The 12, the 16, or the 20? The 12. And we know the hypotenuse is the 20, so 12 over 20, he's right, it is 3/5. And I need the decimal as well. Okay, and then I'm crazy, so I'm going to put 0.60 because the direction said 2 places, so I'm that person. Okay, and the cosine is the adjacent over the hypotenuse. I know the hypotenuse is still 20. What is the adjacent? Yeah, it is. It's 16 over 20, and then you type that in your calculator, and you get... If you had put 4/5 on your paper instead of 16 over 20, you were still correct. And then for tangent, it's opposite over adjacent, which is... I know it doesn't involve the 20 because the 20 is the hypotenuse. Is it 12 over 16? Is he right? Yes, 12 is opposite over 16. 12 over 16. I know that's 3 over 4. Is it 0.75? Good. Okay, and then some freaky stuff is going to happen again. Meaning, the sine of b is going to be 0.80, the cosine of b is going to be 0.60, and then the tangent is going to be 16 over 12. But for those who don't know what Ms. Compton is talking about, I'm going to do it slowly again for the next three. Sine of b is opposite over hypotenuse. The hypotenuse is still 20. That hasn't changed. But since we're looking from b, the opposite of b is 16. So 16 over 20, 0.80. We've already calculated it. Okay, adjacent over hypotenuse, adjacent would be 12. So 12 over 20, we've already typed that in, it's 0.60. Again, notice these answers match. And then for tangent, opposite over adjacent is going to be 16 over 12. It's flipped. And I need to know what that decimal is. I got 1.33.
Oh, wait.
Okay.
Yeah.
So I'm going to come back to these three at the bottom in just a hot second. They're the reasons why you have your calculator. Flip to the back. I'm not being special. I just didn't feel like fixing it, and I was in a hurry to make copies. I get it's the same problems on the top and bottom. If you want to cross out the bottom ones so they don't distract you, that's fine. 1 and 2 involve more than you're thinking. You have to find the sine, cosine, and tangent from J, and the sine, cosine, and tangent from L, and then you have to do the exact same thing on number 2. So I should see 6 things for each problem. And then Addison wishes I would talk about 3, 4, and 5. She wants to know how to do those. Okay, so flip back to the front. If you've got one of my calculators, I don't know what calculator you use. I don't. You're going to need a calculator for this next test. I can promise you that much. Is it smart to have your own calculator? Yes. Once I show Katie how to set her calculator today, since Katie's using her own calculator, it's never going to be messed up. If you're using my communal ones, I cannot promise that. Okay, so if you haven't noticed, there is a sine, cosine, and a tangent button. They have buttons. And even my fancy yellow calculator has a sine, cosine, and a tangent button. Your calculator should have these buttons. If they don't, you need to borrow one of mine, first of all. Second of all, so our first problem says to do sine of 30. I'm going to press sine, and then 30, and then I press enter, and it says 0.5, but more importantly, underneath that 0.5, I see a DEG. I see a DEG. If you're using one of my blue ones, and it doesn't say DEG on the screen, we have an issue. We need to be in degrees. Okay, so again, the last 3 on the homework notes today, and the last 3 on the homework, and a ton on the test, it's just going to be straight up calculator plug and chug. But if your calculator's not in the right setting, you're going to miss every single one of them. So we've got to make sure our calculator's in DEG. It has to be in degrees. If you're not sure, we can check it. So how do we check it on my blue ones? We press the one that looks like degree, DRG. I see options, degrees, radians, or gradians. We want degrees. Now, I did that quickly. As long as you ask me before test day, I will gladly check your calculator for you. Gladly. Yes, the answer is 0.5. Okay. Now, if you use my fancy calculator, and you press sine of 30, and it gives you something that looks crazy, I press mode, and then I make sure that it's on degrees. I want degrees to be darkened in, not radians. Okay, so the answer for sine of 30 is 0.5. And since it said 10,000, I know I'm actually wanting 4 decimal places. So for the cosine of 56, I'm going to say 0.5592. Because when I typed it into my calculator, I got 55919. That other 9 rounds that 1 up to a 2. So I put 0.5592. Are there any questions about that? And then last but not least, I'm going to do tangent 22. And then I'm going to press enter. And I get 0.4040. There's no way to mess this up if your calculator's in degrees. But if you don't check to make sure it's in degrees, it's going to give you the wrong answer, and you're going to miss the easiest ones possible on the test. Now, Katie has a special calculator. If you have a special calculator, and it is not this easy to type in, you press sign and then 30, and you did not get 0.5, you have what I'm going to call a backwards calculator. And I can show you how to use it, or if you want to join the rest of us, you can borrow one of my other ones. It's not that complicated, I just need to show you. It's kind of like if you're an iPhone person and you try to go to a Samsung or an Android, it just gets a little complicated. Okay, you have homework on the back. You want to go ahead and get done. I have tests I want to hand you anyway, so get on your stuff. I'm going